In this video, I want to go over a couple of different topics with networking. First being point-to-point IP addressing, then onto DHCP and DNS and how they work and why we want them in the first place. So rather than doing this physically and trying to manage using a camera and switching back and forth between the desktops and the PCs, I decided to go with Packet Tracer. Now, you may or may not have used this program before if you've had any networking classes. What this program is really good at is it lets you visually see what's going on with the packets as they travel across the network. So in this case, I have two computers, PC1 and PC0 and PC1, and they are both linked up to this networking switch here. Now by default, these computers don't have an IP address. If I go and click on one of these and go to the IP configuration, you can see that there's nothing in here. So in order for these two computers to talk to each other, they need to be on not only the same network, but an addressable address that they can both use. So one of the principles about networking is it's generally the same on every device, and that's by design, because you all want these machines to be able to talk in the same language. So if I wanted to set the IP address to a certain address, for example, on any device, generally it's going to have fields for an IP address, subnet mask, default gateway, DNS server, that kind of stuff. And that's true if you're working on a PC, like with Windows. It's a little bit harder to get to. You have to go into your network connections, go to properties, internet protocol, and then you can set the individual fields for IP address, subnet mask, default gateway. Same is true if you have a Mac. So if you go into System Preferences and then go into Networking or Network, you can see here the same thing, IP address, subnet mask, router, and you can manually set this in Mac as well as Windows to be whatever would suit your purposes for that. And the same is also true on medical devices. If you set up a medical device, generally you will also see the same fields here. So this example will work for basically any device that you're looking to network. So what I'm going to do now is I'm going to set each of these computers to these IP addresses. PC0 to 192.168.0.10 and PC1 to the same thing but .20. The net mask for this network, all these machines are going to be under 255, 255, 255.0, or also known as a /24 network. So I went ahead and set up the IP addressing on these. So if I go to PC1, you can see this is 192.168.0.20, and PC0 is the same but with .10. The default gateway didn't need to be entered in for this. The default gateway is if you were trying to leave the network. In this case, we're just trying to talk to a computer on the same network, so we could have ignored that, but I just went ahead and added it, even though that address doesn't resolve anything in the network. So now that these are set up, I'm going to ping PC0 to PC1. So I'm going to put PC1 away right now and just focus on PC0. I'm going to go back to the desktop, and this would be the same on Windows. Mac would also be the same. You just want to use the ping command and then target IP address. In this case, we want to, since we're pinging from PC0, we want to ping to PC1. So we need to ping its IP address, 192.168.0.20. Now before I send this off, what I'm going to do is I'm going to send this to simulation mode so we can see what's going on in the network. So I'm going to hit enter. And the first thing it's going to do is this computer is going to try and figure out which computer has this IP address. So it's going to send out a ARP packet, which is going to be sent to all devices. In this case, it's just one other device, to see if it matches. In this case, it does match. You can see that it's found a route to that IP address. So now it's going to send its ping packet. Goes to the remote PC and then back to the host PC. If I go back to our command window here, you can see that the one packet we sent, the one ping packet that was sent, was successful. So if I continue this, it'll keep going back and forth. I can actually just switch it back to real time, and you'll see the command window here has sent out 4 packets, and they've all gone to their correct destinations. So one question might come up: what would happen if both of these computers had the same IP address? Where would the packet go to? So what I'm going to do right now is I'm going to set PC1 to the same IP address as PC0. So they're both going to be on .10. Before I change them though, I'm going to set it back to simulation mode, and I'll show you what happens piece by piece. So I have my 2 computers here. I'm going to go ahead and set this computer to .10. And now that that's done, I'm going to start advancing the network traffic 1 packet at a time. So because PC1 has changed its IP address, it's going to send out another ARP request to the network, basically telling it that it has this IP address now. And when it reaches this computer, it's going to say, hey, you have the same IP address that I do now. And you can see on here, PC0, this computer here, has already marked that there's a duplicate IP address detected in the network. And it's going to send back a packet to PC1 saying that you can't use this, I have the same IP address. And you can see here PC1 says this address is already used in the network. Now, this may be automatic. There may be some devices that ignore that. And diagnosing that issue is its own video. But in terms of the networking process, there are things in place to prevent duplicate IP addresses from showing up on a network. So one thing you might realize is that this is kind of a lot of data to keep track of, and even though the network will try and keep track of, make sure there aren't any errors going on with IP addressing, you still need to know, if you're doing this manually, what computer has what IP address, and then not to duplicate it. And you have to manually enter in this information on every machine that you add. So one problem you might think is, well, what if I have a lot of computers? So I just added 3 more computers, and these are all blank slate computers. They have no configuration. So I have to go into each one of these machines and set the IP address manually to each one of these, keeping in mind the ones I've already used. This is a problem, and when you're in a large scale situation like an enterprise or a business, you might have hundreds of computers that you need to assign IP addresses to, and it's just not feasible to do it all manually. So that's where DHCP comes into play. So DHCP stands for Dynamic Host Configuration Protocol, and its primary job is to automate this process. It's there to automatically keep track of what computer has what IP address and automatically issue them if we need more of them, or revoke them if devices leave the network. All this happens automatically with DHCP. So for the purposes of this, I've gone ahead and added a DHCP server all by itself. Now generally in a real situation, a DHCP server would be built into something else. It would be a part of another system. But for this example, I'm going to go ahead and just have it isolated. So all this machine does here is just do DHCP. I've also gone ahead and removed the IP addresses from both of these computers we worked on before. So all 5 of these computers now are blank. They have no IP addresses. So for this, what I'm going to do is I'm going to put this into simulation mode so we can see frame by frame how the packets travel and show you how DHCP works. So for this computer, back to PC0, I'm going to go back to the IP configuration and I'm going to set it to DHCP. And you can see here it's requesting IP address. So what it'll start doing is it will send a request to this DHCP server telling it, hey, I want to join this network. I need to have an IP address to do that. So if I capture forward this, first it's going to check to see where the DHCP server is. So you saw it sent the same packet to all these machines. All these machines down here are saying that I'm not the DHCP server, but this one is. And it will send back a response saying, I am the DHCP server. computer is now going to request an IP address from the network, or from the DHCP server to the network. And I'll keep going back and forth a little bit. So now, back to here, you can see DHCP request successful, and it gave me an IP address. Now, in real life, this happens very, very fast. So if I hit PC1 here and set it to DHCP, not in simulation mode, I'll put it back into real time. PC1, DHCP, it's requesting an IP address, and it's done. And it's sometimes, a lot of times even faster than that. But generally that is the process that it's going through. And in terms of the nitty-gritty details of how these packets work, it's a little bit beyond the scope of this. I've done the same thing with PC2. I've done a DHCP address request. So if I forward it once, you can see here this is the packet with the DHCP information, and in here is going to be the assigned IP address. So this is the IP address that it's going to give to our PC number 2 here. So this sort of leads to the concept of what if you wanted to try and talk to a computer that you didn't know what address it had, its IP address. This could be another computer, like if you wanted to go from computer to computer, that's certainly possible. More commonly, you're going to be talking to a server, usually a remote server on a different network. But for this purpose, for this example, we're going to keep everything on the same network, just to keep it simple. What I've done is I've added another server up here, web server. Its address has a static IP address 192.168.0.3, and its job is really just to act as an example web server. So I'm going to try accessing the server from one of my PCs. So let's do PC0. It has a dynamic IP address from DHCP, so we don't have to worry about that. What we do want to do though is, we want to go to the web browser, and we want to type in the IP address for the server here. So 192.168.0.3. And before I send it off, I'm going to switch it back to simulation so we can go step by step and see how these packets work. So I'll hit go. So first thing it's going to do is it's going to send out an ARP packet that's going to be sent to every machine on this network to try and figure out where the web server is, which machine has this IP address. So if I do it forward and then forward one more, you can see that that packet was sent to all the machines, and all of them except the web server has rejected them. So now the web server is going to send back a packet saying, this is how you get to me, that I am the web server. And at that point, my PC is going to start doing a TCP interaction with the server to get the web page information. So if I forward this a bit, you can see it going back and forth between the PC and the server, and that's just a function of how TCP works and HTTP. But if I go back to my computer here, you can see this is the page that it came up with. And I can do that again in real time. Go back to my PC. And the same thing as before, but it happens so fast that you can't even see it. So that's where it's useful to have this program, is that you're able to slow everything down and see how it works. But one thing that's kind of a bummer is that if you want to talk to the server, you have to type in its IP address. Same thing if you wanted to talk to one of these other machines, you'd have to know its IP address and type that in manually. And generally that's not something we like to do. We like to type in something like Google, google.com. The problem is that computers don't have any idea what google.com means. It's meaningless to them. It needs to have something in place to convert that into an IP address that it can use to connect to. So I'm going to go ahead and add a DNS server, which is the service that takes a domain name like google.com and converts it into something that a computer can connect to. All right, so I went ahead and added another server. Hopefully it's not getting too confusing. This is the DNS server, and same as the other servers, it has a static IP address. This time it's 192.168.0.5. If you remember back when we were configuring the IP addresses though, one of the fields in here is DNS server. And if you were going to fill this in, you would want to enter in, if you were to do this manually, you would need to enter in this field manually to make DNS work. But since we have a DHCP server, this DHCP server is configured to automatically tell all the computers that this is where you go to find the DNS server. So if that's not making much sense, let's just break it down right now and show you step by step how DNS works and how it interacts with the rest of the network. So my DNS server here, if I go to its configuration, you can see here there is a field for requests and records. So there's only one record in here right now. There's a record for website.com, and basically what this means is when it gets a request for website.com, it's to send a response of 192.168.0.3, which is our web server's IP address. So let's switch to simulation and break this down. So I'm going to go to my PC here, and instead of entering the IP address directly, I'm going to go and enter website.com and hit enter. So the first thing it's going to do is, like before, it's going to send out an ARP request to try and figure out where the DNS server is. It goes out to the switch sends it everywhere. Only the DNS server, everything else rejects it except the DNS server. And then the DNS server responds to the PC. And at this point, this computer is going to send a DHCP request asking what IP address belongs, or what does website.com translate to. So it's going to send this to our DNS server, and then the DNS server is going to send a response. Scoot down here a bit. So the request was for name.com, or I'm sorry, the request was for website.com, and its response is 192.168.0.3. So that's going to be sent back to our machine here, and the machine accepts it. And now what's going to happen is our machine is going to talk directly to the web server through its IP address. So it sent out another ARP request to try and figure out which machine has this IP address. And only the web server does, so it sends back a response. And then the computer starts talking to the web server again. And you can see the path that the packets are taking. It's only going from this PC to this server now. And if I go back to my PC, once again, it's now talking to it. So I can replay that. I can go back to real time, open up my PC again, go to website.com, hit enter, and you can see it works the same as before. And everything's there. But one thing to keep in mind is that just because there is a DHCP server, it doesn't necessarily mean that the computer has to use it. So same thing as before, I'm going to use PC1 here. And I'm going to go to, switch it back to simulation, and I'm going to go to just the IP address of the web server. Hit enter. So now instead of first asking where the DNS server is and then asking to translate website.com, it already knows what the answer is. So it's not even going to talk to the DNS server at all. So it tries to figure out firstly which device has the web server responds, and then the packets go back and forth between the PC and the server directly. So if you were to, for example, try and block a DNS record or something, I could take this out. I could set this to be an invalid IP address. I could remove it entirely. You could do that. In fact, I can do it right now. I will actually go right ahead. I will take out, go to DNS, and I'll just turn it off. So now DNS is disabled for the entire network. So I'll go to a fresh PC, number 2. Haven't used that one yet. It's got its DHCP address. I'm going to go to website.com. And you can see nothing's happening. That's because our DNS is no longer responding. And the same would be true if we kept it enabled and just removed the record. it would talk to the DNS server, but there would be no response. It wouldn't have anything matching website.com, or if it did, it would be something invalid. So instead of doing that, now we can once again just type in the IP address and hit enter, and it comes right up. And that's because it's not even talking to the DNS server. The DNS server may as well not even be here. It's able to go directly between the PC and the web server. So some things like ad blockers, for example, use DNS blockers. They block DNS requests, and that's how they're able to block ads. But that doesn't always work if, for example, they have a hard-coded IP address for their server for ads, because at that point your DNS block it's not even going to work. The packets are going to go right through it, right past it. It's never going to see it. So hopefully that gives you a better idea of how IP addressing works, why these systems exist in the first place to automate some of the stuff, and some of the principles surrounding how these services work. But one of the things about this is that everything I just showed you works exactly the same in terms of real computers. So you could set this up with a Windows machine, 2 Windows computers. I mean, these all could be Windows computers. In fact, earlier in the video when we did a point-to-point, we had it going between the... So if I remove this stuff here, it looks something like this. And you could even do this, you could do the same thing without the switch at all. You could link the 2 computers directly to each other like that and set up their IP addresses so that they're able to talk to each other.